Ladies and gentlemen, welcome once again to Deetutorhome. I'm your humble host, Uncle D. Today we are going to be solving questions that are like with questions we are expecting from WAEC on Thursday next week, which is chemistry practical. And the questions we are based on the specimen given to us or sent to us from WAEC. So I'll be able to gather questions regarding that area. So this is going to be like 80% live question. 80% live question on 2023 WAEC chemistry practical. Now look at this question we have before us here. We're given that A is a solution containing 1.03 gram per dm³ of hydrochloric acid per dm³. We said B is a solution containing 1.25 gram of hydrated Sodiumtrioxocarbonate 4. And we have the compound here already. Now, in 250 cm³ of the solution. Now, please, before I proceed further, I want you to take note of this. This is the same specimen that is sent from WAEC. These two reagents that is the same specimen that have been sent for us. So we are going to solve questions regarding them. Now, if you look at this question, we have water of crystallization in this compound. There's water of crystallization in this compound, which make this compound, or regarding they said it is source, but it actually is not really a source. But due to this water and due to the reaction when it dissolves, it's going to form a salt solution. So we have water of crystallization on this solution, and this is our hydrochloric acid. Now we are told that if 25 cm³ of hydrated Sodiumtrioxocarbonate 4 neutralize the acid, we have to calculate A in mole per dm³, B in mole per dm³, and B in gram per dm³, and B in mole per dm³. Then B1 said determine the number of molecules of water of crystallization in this solution. We also have the B2, which is what we should write the chemical formula for the reaction. Now, for these two questions, I will solve them in my next video. Due to lengthening of the video, I will solve these two questions in my next video, but I will try my best to explain this. So the first step you need to take note that is that always remember that the reaction is between the hydrated Sodiumtrioxocarbonate 4 and hydrochloric acid. I go back again, hydrated Sodiumtrioxocarbonate 4 and hydrochloric acid. So the first step there is for us to write out the chemical formula regarding this question number B2. I'm going to write out the chemical formula, and the chemical formula is Na2CO3 times H2O reacting with HCl. Please, due to the specs in my book, I'm going to break down the chemical equation, but it is not allowed in chemistry to break down the chemical equation. Your equation must be in straight line. So if you do that, I'm going to be having NaCl plus CO2 plus water. So the water will collect the X, so we're going to have it in this pattern. And if we balance our chemical equation, not fully wet balance, we're going to have 2 here, then we'll have our 2 here. For this, we have our reaction. This is supposed to be the chemical equation. Now, if you look at this from the reactant part, which is considering these two are the reactants. These two are the reactants. You see that there's no molecules there, which therefore means our number of mole here will be what? 1. Our number of mole here again will be what? 2, because we have 2 here. So therefore, don't forget the Ca that will be given is what we are asked to calculate in this place. So we don't know it yet. Then the Cb, if the Cb, we are asked to again to calculate for it. So we don't know it here. Then our Va, volume of the acid given, we don't know it yet, which is what we are going to use titration to get that. Then our Vb, we're giving it to be what? We're giving to be what? 25 cm, that's 25.0 cm³. Then our Na is equals to 1, Na is equals to 2, our Nb is equals to 1. This is the Na taken as the base, and this is what? The acid taken as what? 2. So therefore, we proceed further. But the first question here is for us to calculate the A in mole per dmq. Now, to calculate A in mole per dmq, you will recall that molecular mass is equals to gram per dmq over mole per dmq. Now, what I mean by gram per dmq and mole per dmq, that means molecular mass is the ratio between concentration of the gram per dmq and the concentration of the mole per dmq. That is the mass concentration over the molar concentration. So we can take this to become what? Mass conc over the molar conc. So anytime questions are given to you in gram per dmq, just know that question is regarding what? Mass is under mass concentration. If it's given to you in mole per dmq, just know it's what? Under what? Molar concentration. So our question is that we should calculate A in mole per dmq. Don't forget, A is the acid. We are taking A as the hydrochloric acid, where we're giving the mass concentration of the acid as this. Look at this. This was gram per dmq. So this is the mass concentration of the acid. Then we're also giving the molar mass of the A is what? Hydrochloric acid, which is what? HCl. So the first thing we are going to do is for us to know the molar mass. So the molar mass is HCl. H, it is 1. Then Cl, which is what? 35.5. And if we do that, our HCl will give us what? 36.5. So this is the molar mass. That's the gram per mole. So this is the gram per mole of the hydrochloric acid. Now, going back to solve our question on mole per dmq, is going to be what? From here, we'll just cross multiply here. We cross multiply here. We cross multiply, so we're going to have this times this equals to this. Though our final answer will become, our final answer, that's this times this equals to this. So our final answer will become molar mass times molar conc is equals to mass conc. So molar mass times molar conc is equals to mass conc. What I did, I just cross multiply, and we are looking for this. This is what we are looking for, mole per dmq. So what do? We divide by side by what is standing with, which is this. So the molar concentration with the molar conc is equals to mass conc over the molar mass conc over the molar mass conc over the molar mass. And if we do that, we are going to have our mass conc is here is 1.30 gram per dmq over our molar mass. We have solved for that to be what? 36. We have 36.5. So if we do that, we are going to be having 0.035 mole per dmq. So I'll go by it again. As the concentration of the A now is 0.035 mole per dmq. So this is how we calculate for concentration of A in mole per dmq. Now going to the concentration in B in gram per dmq, we go back to the B solution again. We have the mass. So gram per dmq, I told you earlier on that is mass concentration. The mass conc is equals to the mass over the volume, which is in dmq. The volume must be in dmq. That means if you are giving the volume in cnq, you have to divide by 1000 to have the volume in dmq. Now, to get that, what is the mass? We're told the mass is was 1.25. 1.25 divided by the volume. The volume was given to us as 250. We have 250. Don't forget, this volume is in cmq, so we're going to divide it by 1000 to have our dmq. If you do that, we're going to have 1.25 divided by 0.25. And if you divide further, we are going to have our answer to be 5.00 gram per dmq. Now, that's how we solve questions regarding mass concentration. Mass concentration is the ratio between the mass of the solute and the volume in dmq. The ratio between the mass of the solute and the volume in dmq. While the molar concentration is the ratio between the mole of the solute and the volume in dmq. While molar amount is the ratio between the mass concentration and what? The molar concentration. Now the last question we are going to solve here is B, the concentration of B in mole per dmq.